Hello.
Hi, everyone.
All right, welcome back to Astronomy on Tap. It's time for Astronomy in the News. I am AstroBit.
And I am Major Merger.
All right, so first up, you might remember this from a couple of months ago, the Space Poop Challenge. Oh, what happened?
Are
we in auto-cycling mode again? Nope. Other way.
Spoilers!
There we go. Okay. Space Poop Challenge. So we first talked about this back in November. NASA set up this challenge to figure out how to deal with poop on Mars. So they're worried that astronauts might have to spend up to 6 days in their spacesuits. There's things you have to do in 6 days that aren't very pleasant to do in a spacesuit. So they set up a challenge to ask the public to figure out ways to deal with this. Yep, it's auto-cycling. We're going to have to... So they set up a challenge, offered prizes for the public to come up with solutions. They just announced the solutions on February 15th. Such a fantastic post-Valentine's Day present. The winning prize was $15,000, went to Dr. Thatcher Carden of the U.S. Air Force. He is based here in Texas at Laughlin Air Force Base. He is a flight surgeon and considered principles of laparoscopic surgery, where you insert really tiny things in tiny holes. He designed a method of creating a tiny airlock in the spacesuits in order to take things in and out, including diapers and baggies and things that can get rid of things. Let's see.
How many euphemisms?
Only a few. So the second prize winners went to also a group from Texas. So a group of doctors, Catherine Kin, Stacy Marie Louise, and Tony Gonzalez. A dentist, a physician, and a chemical engineer, I think it is. And then the third prize of $5,000 went to Hugo Shelley from London. Their methods basically figured out ways of keeping the waste in the suit. Not necessarily quite as fun, but taken care of in a way that this astronaut doesn't have to deal with it for a week. These designs are all going into testing from here. They're going to be flown on the International Space Station at some point in order to figure out how well they work and what is actually feasible. All right. Oh, wrong way. There we go.
Okay, a little maybe more pleasant talk now. Kentaro Terado and researchers from Osaka University have found a particular type of oxygen isotope hidden in the lunar soil using two instruments on Kaguya, which is a lunar probe launched by the Japan Aerospace Exploration Agency back in 2007. So oxygen-16 is an isotope that occurs on Earth, and it appears that the moon has been slowly collecting it for the last 2.5 billion years, or since plants began to photosynthesize on Earth and produce oxygen. So the way they believe this works is via a funneling mechanism shown in the picture here, aided by the Earth's magnetic field. And so when the moon passes out of the sun's view, it's in this region where the Earth's magnetic field stretches out into space, known as the magnetotail, which kind of sounds like a Pokemon to me, but okay. So charged particles from the Earth, including ionized oxygen, flow along these magnetic field lines, making their way to the moon's surface and become embedded in the moon's soil. And so Terada and his team suggest that perhaps thanks to this mechanism, the Earth's atmosphere, as it was billions of years ago, may be preserved on the lunar surface.
Other way.
Oh, it's me again. Okay. So as you all may know, black holes have puzzled astronomers and physicists since they were originally hypothesized. But unlike supermassive black holes, which we know reside in the center of galaxies, intermediate mass black holes, which are between 100 and 10,000 times the mass of the sun, have been harder to pin down in terms of where they can be found and how many of them there are in the universe. And we've switched to the other side. Okay. So a handful of these mid-sized black holes have been found in galaxies due to the massive amount of X-rays they emit from material falling onto them. But now it appears that these intermediate mass black holes have been found in the center of a globular cluster of stars shown here. So Bulent Kizilton from Harvard Smithsonian Center for Astrophysics and his co-authors claim they found a black hole between 1,400 and 3,700 solar masses at the center of a globular cluster of stars nearly 17,000 light years away from Earth. But instead of looking at the X-ray emission like we normally do, they've measured the motion of pulsars within the clusters and found signs of a massive compact object at the heart of the cluster, which is driving their motion. But in order to say more about these intermediate mass black holes, we just need to find a lot more of them, and clearly that's a tricky problem.
I will note, so this is a Nature paper. We in astronomy have a term for articles that show up in Nature, which is bullshit. This is actually a very, very, very interesting result, but I've read the paper. I'm not fully convinced. They use some, I don't know, kind of shady modeling and statistics, I think. So take this with a giant grain of salt, or maybe a giant black hole. Okay, next up, scientists or astronomers have discovered a supernova, an exploding star, within about 3 hours of the explosion. This is tremendously exciting for all of us. I personally study supernova. Dr. Montgomery was talking about how he watches white dwarfs and hopes that explodes every time they get a little bit brighter. I really hope they do too. We have seen 3 stars explode. We have caught 3 stars within a day of their explosion. The problem is we're looking up at the sky. We only, we look at different parts of the sky. We hope to see something change. When we see something change, sometimes it's a supernova. But the problem is we're not watching the entire sky all the time. So it's extremely rare to be able to find these things. So supernova 2013 FS. This is the bajillionth supernova caught in 2013, technical term. So we were surveying the sky and we happened to catch it within 3 hours of the explosion. This is incredibly important because it gives us a lot of details about what things look like right outside of where the star explodes. So we caught the star exploding. We managed to take pictures of it and get spectra within the first 6 hours. There's only one supernova that we've ever caught within that period of time. That's 1987A, which happened in 1987. Astronomers amateur astronomers in Australia caught it within 4 hours of the explosion. But the supernova was 160 million light years away from us, and it shows evidence for crashing into stuff that the star blew away within the last year. So something like the wind that our sun has, but a million times stronger, and the supernova went off, crashed into the stuff, became really, really, really bright, really, really, really hot, and it's something that we've never actually observed before in a supernova. So it's very exciting. Other way.
Okay, and this last bit of news is very near and dear to our hearts here at AoTX. That involves one of our founders, Dr. Rachel Livermore, aka MC High Z. And I believe she's in the audience. I'm pretty sure I saw her. So yeah, okay. So everyone say a little prayer for me that I don't screw up her science right now. So Dr. Livermore and colleagues have created a new technique to hunt down the earliest generation of galaxies in the universe. And by combining these Hubble, not him, he had nothing to do with it.
MC High Z.
But by combining Hubble Ultra Deep Field images and an analysis technique known as Wavelit Decomposition, Rachel has been able to computationally remove light from foreground galaxy clusters to see much fainter galaxies that lie beyond. So what makes finding these first galaxies so tricky is that the foreground cluster is needed to gravitationally lens and boost the signal of the background sources. But the boost to the signal is not alone, and then their light is still needed to be subtracted to get the full detection of the source. So Rachel and fellow scientists have discovered 167 galaxies that are 10 times fainter than any previously known. So if you needed any more proof that Rachel's a total badass, there's a little nugget of evidence for you.
All right, and last up, some sad news. You probably heard about this last month. This happened just before the last Astronomy on Tap. Gene Cernan, the last person to walk on the moon, passed away on January 16th. He was inducted into the field of astronauts in 1963. He was the third with the third group. He flew 3 times in space. First in Gemini 9, where he took what was called the spacewalk from hell. His suit overheated, and he started tumbling because the device that was supposed to help him kind of keep track of where he was didn't work very well. So yeah, he had a pretty unpleasant time up there. He next flew on Apollo 10, which was, you probably remember Apollo 11 when we actually landed on the moon. He was on Apollo 10. They flew to within 10 miles of the lunar surface. He says he set the white line for Neil Armstrong and Buzz Aldrin and Michael Collins to follow in order to get there. That was about 3 months before the actual landing, and then finally he flew again his last time on Apollo 17, the last mission to the moon, 1972. He was the last person to stand on the lunar surface. He was the last one to re-enter the module in order to come back to Earth. So he was the last person on the moon. He retired in 1976, entered the Astronaut Hall of Fame in 1999. He is greatly missed among all of his colleagues and all of us astronomers. Thank you, Gene. Okay, and assuming that I can press the slides correctly, that is all we've got for Astronomy in the News for February. Thank you all for coming.
Thank you.
We'll hand it off